works. Been there a year and a half. Spent a couple of years here in Jacksonville, Florida, working for a healthcare payment processor. Spent 6 years at Microsoft in the online services behavioral targeting group prior to that, and the rest of it probably doesn't matter outside of the fact I have a whole lot of years as a partner in a business, which is where my interest in big data and really the use of big data comes from. Excuse me, getting over a little bit of a cold. So I expect you'll be thrilled to know I have a total of 2 slides today, one you're looking at and one at the very end. So we're going to talk about Azure machine learning, the whole the analytics platform, data mining component of the Azure ecosystem. Let me kill this PowerPoint real quick. And we will come back to this later. So let me show you quick images here. So off in the middle of this new Azure module is our machine learning environment. So you should understand that this is about 3/4 of the way through the whole data science methodology, and this is very definitely data science. This is something, if you're going to spend much time with this, you're going to have to learn about data science and the process behind it and how it works. And excuse me. It's going to be important to know that, to understand what these what all these models are and what all these things do and how this whole process works, which is what I'm going to talk through today. And I'm not going to do it. I'll do it with this particular example in some detail. It'll give you a pretty good place to start from. So in that this is 3/4 of the way through, let's talk about the dependencies here. So every experiment needs data. So where does that come from? You can, in this environment, you can pull it in directly by using data readers. You can pull it in, which you can pull in from websites. You can use saved data sets. You can pull data sets in and save them to your own library. You can use the Microsoft experiment library, all the lab libraries. Or you can process this data somewhere else. You can certainly use HD Insight, use HivePig, everything else over on the HD Insight side, understanding that you'll be reading in from a file and writing out to a file, and you'll be putting that file somewhere, probably on Azure Storage as a blob. So let me go back here real quick. So the machine learning readers can reach out to any storage that you have set up in Azure. So let's talk a little bit about this whole Azure platform. For anybody that doesn't understand what it is, it's a giant ecosystem of it's a platform for creating, managing machines, networking, etc. There are a couple of images here for you. So it's as a service. So there's platform as infrastructure, platform as service. Azure offers a variety of options for building out machines, for spinning up SQL servers, for spinning up web servers. And they manage it through this larger set of services than this, but this is pretty much trying to give you some idea that it's not just, okay, it's a machine here, a machine there, virtual machines, of course. And of course they are scattered or can be scattered all over the planet. Yes, this is fuzzy, but it's really just to give you some idea of how much effort Microsoft has put into this whole Azure thing. Not all of these locations are available for HD Insight, and not all of them are available for Azure Machine Learning. Again, that's changing very rapidly. This machine learning module is pretty new, so you can expect a lot of changes certainly over the coming months and years. So the whole data science process starts with getting and cleaning data. So where do we get it? Actually, it starts with identifying a question to be answered, and from there, figuring out what data you need, what data you have, what data you could collect to augment your analysis. The more varied your data, the better your predictions are likely to be. That doesn't necessarily mean that if you do an analysis over 300 variables, you're going to get a better prediction, because a lot of those variables could be noise, or they could actually be detrimental. We'll talk about that in a little bit. For this exercise, I'm using a flight data set. It is looks like this. It's already cleaned up for us mostly. There are a few things that we need to do for the algorithm that we're going to run, but for the most part, it's already converted into nice, neat-looking columns and well-defined variables and limits and data types, that sort of thing. However, it's not exactly what we need, and we'll probably find some things in here that are really nothing but noise. The idea with the noise is that any variable in here that, if it's not what we'll call categorical, if it has low granularity, if there's two values in here across say 100,000 rows, and it's not a Boolean, then that column is probably just going to distract the algorithm. It's probably just going to be noise. Cases where everything is the same, cases where you might have nulls in important places in here, you may choose to get rid of those. In most cases, you would. If you have nulls in particular columns or particular variables in the data science world, you would need to decide what to do with those. Whether you leave them at 0. In many cases, you'll see a practice of adding 1 to everything, such that you move all the zeros away from 0, and that leaves empties as empties, and you can then distinguish between them. You convert your empties to zeros at that point. You may choose to